Hi, I'm TV host and professional big brain guy, Garb Henderson, and today I'm going to be talking to you about ocean acidification. From the 1700s to now, ocean acidification has raised by 30% and continues to grow. But what is acidification? The term acid gets thrown around a lot, and a lot of people think of it as a green bubbly liquid that dissolves everything in its path. But acidity is really just how much of a hydrogen ion is in something. When a substance has a lot of hydrogen ions, it's acidic, and when it doesn't have very many, it's basic. And so 0 is acidic, there's a lot of hydrogen ions, and 14 is basic, and then the middle is 7, and that's called the pH scale. Naturally, the ocean is about an 8.1 pH scale, which is pretty basic. It doesn't sound that basic, but that's because the pH scale moves as factors of 10, like earthquake scales. So the difference between 7 and 8 is a times 10 factor, or the difference between 7 and 9 would be times 100, so it exponentially gets larger. The way that ocean acidification works is when carbon enters the ocean through the carbon cycle, and if you don't know what the carbon cycle is, too bad, because my job is not to teach you about the carbon cycle, it's about to teach you about ocean acidification. Anyways, what happens is when CO2 enters the ocean, it creates carbonic acid, which sheds its one hydrogen ion to either make carbonate or bicarbonate. And that one hydrogen ion then goes off into the ocean because it's lonely and is a mess. So the ocean is filled with all of these hydrogen ions, which is great, the ocean's acidic. But why is ocean acidification a problem? Well, why don't you just take my word for it? Stop asking me questions, because it's just a problem, okay? It's bad. Calcium carbonate is very important in the ocean's ecosystems because it creates the bone structure, the tough exoskeleton for a lot of crustaceans, such as shrimp, crab, lobsters, all those things, and sea urchins, and all the tough things, as well as coral reefs, which are really, really important to the ecosystems and the shores. And calcium carbonate is what creates all of that. It's what feeds all of the bone structure-y things in the ocean. But carbonate and calcium, which makes calcium carbonate, are the two ingredients. And carbonate is lazy and will just form with whatever is the easiest to form with. And it happens to be those spare hydrogen ions that are just floating around because they're lonely. And so then you get carbonate and those hydrogen ions, and then they form and you get bicarbonate instead of calcium carbonate. So all those creatures that need calcium carbonate to survive no longer have it and become weak, and their bone structure gets all gross and not working very well, and their shells become soft. Now you may be thinking, Garb, why are you telling me this? What can I do to help? Well, the thing about ocean acidification is just like global warming, it's all just carbon emission stuff. So anything you're doing for global warming to help with carbon emissions, you can also do for this. Basically the same stuff, walking more, get your legs swole, take planes less, eat less red meat because cow burps and farts are going to destroy our planet. You know, get more locally sourced food because shipping food all over the earth and refrigeration is all difficult. Turn off your electricity when you're not home. All that stuff. And the biggest and most important thing is spread the word. I think I did my part by making this video, and this has been a public service announcement. Thank you for your time. Have a nice time dealing with the climate apocalypse.